So we were doing a discussions. We were doing a discussion on Legendre's polynomial yesterday, and today we are going to start with the same discussion. And we were doing a few questions that were asked in the examination, and we'll move in that direction today also. Right? So. mm, just let me wait for a few minutes so that people can join, and then we shall move along. Okay, we should just do it. Okay, so let me share the screen. Okay. Okay, so here you are. So yesterday we were having some discussions on Legendre's polynomial. Let us start with the same discussion today. Okay, so the question was asked in net exam. This was asked in net exam, and question says that the generating function for Legendre's polynomial. So they have supplied you the generating function of Legendre's polynomial is f x comma t, and they have given it as equivalent to 1 upon 1 minus of 2xt plus t square raised to power 1 over 2. And they are trying to say what will be p3 minus. So you can do it in a very easy sense. I have already taught you that pn1 would be equals to 1. Pn1 is 1. And we have already studied that Pn minus 1 is nothing but it is equals to minus 1 raised to power n. So that is, it is equals to 1 if n is even, and it is equals to minus 1 if n is odd. Okay. Otherwise, also you can see if I just replace it at the place of x minus 1. So what I'll get? So let us write at x equals to minus 1. So at x equals to minus 1, we will have this. So this is a question in net examination where the question was asked that the generating function for p and x is fx comma t given by 1 minus 2xt plus t square raised to power 1 by 2. And then it was asked what is p3 minus 1. So I've already taught you that pn minus 1 is minus 1 raised to power n. You can straightway give an answer. Or if you don't remember that thing in exam, you can just take expansions of it. So the expansion of it will be 1 plus 2t plus t square ki power 1 upon 2. Or you can simply write 1 plus t ka whole square, and then you can have minus half written all over here. So it will be 1 plus t ki power minus 1. So it is equal to summation pn minus 1 t ki power n, and it is equal to writing 1 minus t plus t square minus t cube plus t ki power 4, so on and so forth. And you can compare on both sides. You can compare on both sides. You can compare on both sides, and that is p naught plus p1 minus 1 t ki power 1, p2 minus 1 t ki power 2, p3 minus 1 t ki power 3 dash dash, and here you have 1 minus t plus t square minus t cube plus t raised to power 4. All these things you can see on the both side. If you compare, you get p3 minus 1 is equal to the is equal to the coefficient of t cube, that is p3 minus 1 is equal to minus 1. Okay, so such questions are asked in examinations. So time and again you will see such questions. Now there is a question which was asked in TFR. However, it is not related to Legendre polynomials, but the question says that the generating function for a set of polynomials, like they have, let's say, for a set of polynomials is given by, so is given by f of x comma t is equals to 1 minus 2xt plus t square raised to power minus 1. They are asking the third set, the third polynomial. The third polynomial, that is, they're saying order x square in this set. In this set is given by which of the following? So option number A is 2x square plus 1. Option number B is 4x square plus 1. Option number C is 2x square minus x. And option number D is 4x square minus. Okay, so these are the four options that you have to write with, and one needs to find which of the following set will, which of the following would be the uh, third polynomial, by which they mean. Okay, so this is what we have to do. So generating function for a set of, I think this is easy question again. How to go about it? So, okay, so it says that, so let us write that these set of polynomials, I'll write these, the set of, basically the set of polynomials be represented by, मान लेते हैं the set of polynomials is represented by q and x. ठीक है? Okay, so that implies 1 upon 1 minus of 2xt plus what it was 2t square की power sorry, upon 1 is equal to summation. Now you have qn x and then you have t raised to power n, and then you have what I can write here. I can write n equal to 0 to n equal to infinity. So if I want to find if I want to find the expansion, if I expand on both of the side, then the term sorry, the polynomials which contain the order x square, we have to just see them. I mean, we have to just see them from both of the sides. Just try it once. Okay. So what we can do, so what I'll do is I'll simply write one. I should take, I think something common out from here. So let's say I take t common out, and then I have 2x, and then again have minus t, and this whole is to power minus. And for any rational index, 1 plus x to power n is given by 1 plus nx plus n into n minus 1 upon 2 factorial x squared, so on and so forth. Okay, so for any rational index, this is your expansion. So 1 plus nx plus n into n minus 1 x squared, so on and so forth. So if you try to write this, what you'll get 1 plus t, and then you have 2x minus t. Again, you have this t squared. You can write 2x minus t squared plus t cube, and then you can write 2x minus t ka whole cube, so on and so forth. And you have to just compare on both sides. Not even this, you just have to see, not even this, you just have to see which is the term which contains order x squared, which is that term which contains order of x squared. You don't have to see this also. So if you just add these terms up, so what you'll get, let us see, 1 plus, so you have 2xt here, so I'll write 2xt here. Then you have minus t square, I'll write minus t square here. Then again you have this t square here, I'll write t square here, and this will be 4x square minus 4xt plus t square, and then you have this t cube, and you have sorry, get the t cube, and then you have this. I'm not going to see all these terms because this will obviously contain a higher term, like it will not contain the term x square. So if you compare on both of the sides, and if you see what is the term which contains x square, so you can see the term corresponding to like here you can see that there is a possibility of term. So I'll write plus here. So I will write up नहीं t square is right. Yeah, t square है ना. अच्छा, okay. So here you will एक काम करते हैं, t square ही था क्या? So we will do one thing. Okay. So summation, we'll do one thing. We will एक काम करते हैं, लीनियर टर्म्स एक से करते करते 2xt, then 4x square, and then you have -1, and then you have t square, then t क्यूब वाले टर्म इकट्ठे करते हैं। t क्यूब वाले टर्म यहाँ से भी कुछ आएंगे और यहाँ से भी कुछ आएंगे, आई एम नॉट बॉदर्ड अबाउट इट, and this will be q and x, and then you have t cube power. So obviously you can see the coefficient of t square only contains a term in x square. So your q and x, or you can say of order 2, is nothing but it is equals to 4x square minus, and I hope this is an option somewhere. So this is your option. So this was asked in TF exam. Is that clear?
सर ये बायनॉमिनली एक्सपेंडेड ना?
हाँ हाँ हाँ। So एक
सर तो फिर वो चीज लेस देन 1 होगी, ये कैसे प्रूव करेंगे?
देखो अपन क्या करते हैं, देयर आर टू काइंड्स ऑफ, लाइक वन ऑफ देम इज क्या कह सकते हैं, मैं कैसे बोलूं इस चीज को। सो देयर इज अ, मैं यहाँ लिख देता हूँ। Okay, so there is one of the theorems which is called as binomial theorem, right? So इसका less than one कैसे prove करेंगे? So let me think about it now. इसको मेरे को सोचने दो एक बार, right? So whatever I thought was this much only. नहीं, I was actually thinking while I was doing this problem कि इसमें conditions questions में नहीं given है कि how to make mod x less than 1 or mod 1 minus 2 less than some. So we'll anyway, well, anyway we can write this thing as this particular thing would be valid uh, only if this particular term, that is 1 plus x. So this particular term should be less than 1. I mean, ये अपने को देखना पड़ेगा. We'll have to see it. मतलब इस question में it is not given. I don't know why, but the question which I am reading right now was asked in TFR 15, and there was no such conditions given to us. So, but however, what I feel is if when like these questions are done this way only, we'll have to, I mean, we'll have to see, we'll have to see कि मतलब कौन सी ऐसी condition, because here there are no such conditions given to us, and there is no such hint which may right now tell me कि इस तरीके से इसको, चलो देखते हैं इसको भी ना एक बार के लिए, just अंडरस्टैंड इस तरीके से क्वेश्चन होगा, बिकॉज इसने पूछा क्या है, इसने पूछा यही तो है कि एक्स स्क्वायर के कोफिशिएंट, मतलब थर्ड पॉलिनोमियल एक्स स्क्वायर जिसमें आ जाए। सो मतलब थर्ड पॉलिनोमियल मतलब जो टी स्क्वायर से जिसका जिसका कोफिशिएंट टी स्क्वायर के कोरस्पॉन्डिंग जो कोफिशिएंट है दोनों साइड कंपेयर करने। एंड वॉट एवर यू आर सेइंग इज ऑल्सो राइट, बिकॉज लाइक binomial theorem is only defined is only a convergent series if 1 plus x e power n is such 1 plus nx and all those things you can write only if mod x is less than 1. This is something that we know already. So from here, what we can assert is, right now we can assert that t 2x minus t ka mod should be less than 1. The problem here is that we have two variables, not a single variable. So we should have some condition somewhere, but somehow it is not given to us. So just give me a minute or so, फिर मैं देखता हूँ इसको एक बार चेक करते हैं, तब तक हम लोग दूसरा क्वेश्चन करते हैं। Okay, so another question that was asked. Okay, एक मिनट, हम लोग ने तो कोई जनरलाइज्ड रिजल्ट ढूंढता होगा वैसे इसका भी, because if TFR has asked, they are all mathematically correct people. They will not ask you wrong questions for sure. So let me take another question which was asked again in net exam. So that is a good question. That question says that the generating function gtx, so they have given to you gtx. Now, instead of x comma t, they have given t comma x, and these are all apparent difficulties that are thrown to the students, because actually क्या होता है, जैसे ये दिखा they will make certain mistakes because उनके दिमाग में कुछ चल ही रहा होता है। For Legendre polynomials is ये ऐसे दे रखा है, g t comma x is given by 1 upon root over 1 minus 2xt plus x square is equal to summation. They have written n equal to 0 to infinity, and they have written t and t x ki power n. And this was asked in net exam only. Okay, and for like here it is given. See, in net exam they have given mod x to be less than. Okay, so they have given mod x less than 1. So probably in question they have missed something, or probably they want one should understand by his own that, I mean, this is less than 1 or something. But somehow in net exam it is given mod x is less than 1, and then they have written if the function is defined by an integral equation. So what is an integral equation? An integral equation is one where the solution also appears under the integral sign. Like uh, if the if if the function, if fx is defined by integral equation given by 0 to x fx dash dx dash. देखो जो फंक्शन तुम्हें निकालना है वो खुद एक इंटीग्रल के साइन के अंदर है, इसी को मोटी मोटा इंटीग्रल इक्वेशंस कहते हैं। मतलब ये बहुत बड़ा टॉपिक है। लाइक लेकिन अभी के लिए इतना समझो कि जैसे फॉर एग्जांपल यहाँ पर नॉन फंक्शन के एफ एफ एक्स वो खुद इंटीग्रल के साइन के अंदर है, इज इक्वल्स टू एक्स जी वन कॉम एक्स। अब इसमें बोला जा रहा है इट कैन बी एक्सप्रेस्ड in it can be expressed as. Now option number 1 which was given to you in the exam was option number B. It was given to you was on option number D. It was given in the exam summation. Okay, so here in the net exam it was given mod x lesson. So they're allowing you to use binomial expansion, but somehow in the upper question it was not given. But however, like you can take that as a granted right now, because even if they've forgotten, this might be the best possible scenario which I've written. So this was asked in net exam. Now you see how to go about these problems. So how to go about these problems. So let us once try. देखते हैं एक बार इसको। So देखो बोल क्या रहा है उसी से करने की कोशिश करते हैं। Let us try to understand what it is giving. So पहले काम करते हैं। It is saying that g1 comma x is given by integration 0 to x, and then you have this fx dash, and then you have dx dash, right? यही तो दे रखा है। This is what it is given. That fx, which is a function, if a function fx is defined by the integral equation fx dash dx dash is equal to, it can be expressed as. So we need to find what is your fx. How you can express your fx, that one needs to find. So first let us find what is our fx. So fx dash dx dash is equal to x g1 comma x. So let us first understand what is g1 comma x. So g1 comma x is simply writing 1 upon root over 1 minus of 2xt. Instead of t we have to write 1. So instead of t we have to write 1. So I'll write 1 here. 1 minus 2x, and I'll write plus x squared. And we know that if we like this is we already know that this will express what. So if in the place of t if I write 1, so it is like equivalent to writing 1 here. So I will write it is equivalent to writing okay. So it is equivalent to writing 1 here. So instead of t I'm writing 1 here. So this is how it is. Okay, is that clear? And we already know like this is 1 upon root over you can write x minus 1 का square, or 1 minus x square, whichever thing suits you. Okay, but understand the point that it was already given that like this. I already taught in the very first day that root over x square is always equals to modulus of x. Understand? Because you see, if I place 9 here, I cannot give two assignments to it. I cannot say it is equal to 3, it is equal to minus 3. So what has been selected that whenever you are saying a square root of a number, you must write a non-negative square root. Okay, so in order to remove this discrepancy, we know that root over x square is modulus of x. So I'll write 1 upon root over की जगह हटाया modulus of x minus is equal to summation n equal to 0 to infinity, and then we have x की power n, and then you have p n 1. Sorry. Okay, and we know that since mod x is less than 1, since mod x is less than 1 implies x lies between minus 1 and 1. So mod of x minus 1 can be written as 1 minus x, because अगर ये x minus 1 लिखा और ये नेगेटिव हुआ तो नेगेटिव अगर मतलब x minus 1 से 1 हुआ और उससे एक और घटा दोगे तो it will be negative. So mod of x minus 1 we'll write 1 minus x. So I'll write it as, so I'll write g 1 comma x as simply 1 upon 1 minus x, and this is equivalent to writing summation n equal to 0 to infinity, and it is equals to x की power n, and then you have pn. Is that clear? क्या नाम है इसका? Is that clear?
Yes, sir.
Okay. So अब अपन क्या कर सकते हैं? Let us see. So ये बस को चेक करते हैं. So you have अच्छा ये सारे ऑप्शंस जो दे रखे हैं हमें इस तरीके से दे रखे हैं कि we'll have to do something about it, right? अच्छा ये सब किसके बराबर है पहले वो भी देखें ना. Let us see that also. So this is equivalent to, अच्छा this is equivalent to x and p, ये तो हो ही गया, and g1 comma x we already know. So what should I write? Okay. चलो देखते हैं. एक इधर देखते हैं, इसको पकड़ते हैं यहाँ से. तो अगर मैं इसका डेरिवेटिव करूँ तो भी काम नहीं चलेगा ना. चलो एक काम करते हैं. सो लेट अस फर्स्ट ट्राई टू फिगर आउट करना क्या है. सो हमारे पास क्या है, इंटीग्रेशन 0 से लेकर x दे रखा है, एफ एक्स डैश डी एक्स डैश दे रखा है, और यहाँ पे दे रखा है x इंटू जी ऑफ 1 कॉमा एक्स, राइट. एक काम करते हैं, पहले लेट अस ट्राई टू इसको बाहर निकालने की कोशिश करते हैं. सो एक काम करते हैं. There is a formula called as Newton-Leibniz formula for the derivative of function whose integration is sought. So for example, if this is the function, ये किसका function है, x का है कि t का है? This function that I have written, is it a function of x or it is a function of t? First let me know.
It's t.
This is a function of t. So let us differentiate this function with respect to t. Okay, and here I am for simplicity keeping it as a single variable function. Otherwise, then there will be a partial derivative term inside these functions. So I'm keeping things simple. So what this derivative is equivalent to, you just place upper limit here, and you do the derivative of upper limit minus, you place the lower limit, and you do the derivative of lower limit. And this is quite simple to say that if you write it as capital Fx and then you place x here and differentiate it, you will get the same result. So this is sometimes referred to as Newton-Leibniz formula for differentiating under integral sign. Okay, so this formula you just remember so that और अगर इसको समझना है तो it is very simple. Let's say if I am saying that in my fx dx, the primitive or integral is capital Fx, and let's say lower limit is phi and upper limit is psi, then it will be equal to lower limit phi and upper limit psi. So if you differentiate it, this integral, it will be equivalent to differentiating capital F psi minus capital F phi. So d by dt of capital F. So d by dt of capital F will again give you small f only, small f psi, and then you psi ka derivative psi dash t minus capital F ka derivative again would come as small f phi and then phi dash t. Is that clear? So this result will come up. Bharat, is that clear or should I write it in a better way?
Yes, sir. Clear, sir.
Clear है ना? ये तो बिल्कुल standard 12th वाला है. ठीक है. So I hope this is quite clear. So अब हम करते हैं. Let us. Why I'm doing this? Because I'm not finding a way from here. So I need to somehow see कि इसका answer क्या है. So f of x will be equals to g 1 comma x, and then I should write x into g dash 1 minus 1 comma x. Is that clear? And which is equivalent to writing 1 upon 1 minus of x plus I should write x into, I think this will be 1 upon 1 minus of x ka whole square, because there will be a negative minus 1 upon 1 minus x ka square, and then there will be again a negative negative, because see, 1 upon 1 minus x would give you minus 1 upon 1 minus x ka whole square, and then the derivative of minus x. Is that clear? Or am I doing something
Yes,
wrong? इसको चेक करते रहना ना, कहीं गलती हुई और फिर अपन गए काम से. So let us write it as 1 minus x common out. So 1 plus x upon 1 minus x. And I think you take this 1 minus x there. So I think you will get simply 1 upon 1 minus x ka whole square. Is that clear? So fx, I'm getting 1 upon 1 minus x ka square, right? है ना, यहाँ तक तो सही है ना? I think we are right now 1 upon 1 minus x का square. अब now let us see the options. Options जो दे रखे हैं, they are given
सर
in.
न्यूमरेटर नहीं आएगा क्या लास्ट वाली टर्म में?
इसको 1 माइनस एक्स को यहाँ लेके जाओ, 1 माइनस एक्स प्लस एक्स, एक्स एक्स कैंसिल हो जाएगा तो
अच्छा
1 ही
अच्छा,
रहेगा.
ओके 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 ओके.
सॉरी ये एक्स है ना, इसको एक्स लिख देते ढंग से, ठीक है. ओके, सो दिस इज हाउ इट विल बी. सो एफ एक्स आ रहा है हमारा 1. अच्छा, अब थोड़ा ध्यान से देखते हैं कि हमारे ऑप्शंस कैसे दे रखे हैं. सो ऑप्शंस एक्स की पावर एन, एक्स की पावर एन, चलो देखते हैं. सो ऑप्शंस जैसे दे रखे हैं, इट रिक्वायर्स अस टू यूज दिस काइंड ऑफ, लाइक इट रिक्वायर्स अस कि जी वन कॉमा एक्स को ऐसे लिखें, राइट? मतलब जो ऑप्शंस हैं, it requires from us कि we should write g1 comma x in this fashion, right? ये हुआ इसका मतलब. So let us use this particular result here. So मैं यहाँ लिख दे रहा हूँ, देखो g1 comma x क्या हो जाएगा. I think it is given as summation x की power n, and then I'm saying क्या था वो, शायद pn1 था, एक बार और चेक कर लेंगे, n equal to 0 से infinity, ठीक है, राइट? ऐसे कुछ तो चेक करते हैं ना, x
यस
की
सर.
पावर n pn1 था, राइट? सो अब देखो, 1 माइनस एक्स, एक काम करते हैं, एफ एक्स को लिख देते हैं 1 माइनस एक्स इंटू 1 माइनस एक्स, राइट? और 1 माइनस एक्स क्या हो जाएगा, इट विल बी समेशन एक्स की पावर एन पी एन वन मानते हो. और दूसरे पे काम करो, दूसरे इंडेक्स से बताओ, क्योंकि दूसरे इंडेक्स से नहीं बताओगे तो होगा क्या, दूसरे इंडेक्स से नहीं बताओगे तो होगा क्या, दोनों स्क्वायर हो जाएंगे. तो लेट मी राइट एक्स की पावर एन पी एम वन. इज दैट क्लियर? देखो, अगर एक इंडेक्स से बता दिया तो वो स्क्वायर नहीं हो जाएगा इसका. सो कीप इट जनरल. इज दैट क्लियर?
ओके सर.
ओके, अब एक काम करते हैं, थोड़ा सा एक आइडिया लेते हैं इसका एक्सपेंशन कैसा होगा. सो लेट अस राइट अ फ्यू टर्म्स एंड देन वील बी एबल टू अंडरस्टैंड द पैटर्न. तो ये हो जाएगा पी नॉट वन प्लस एक्स इंटू पी वन वन, और एक एक्स स्क्वायर तक खोल लेते हैं, पी टू वन तक कर लेते हैं, ठीक है, यहां से आगे नहीं जाते. एक तो ये है, फिर कुछ टर्म्स आएंगे, भूल जाओ इन सबको. एंड देन देयर वुड बी टर्म एक्स की पावर जीरो, तो यहाँ पर क्या आएगा, पी नॉट वन. एंड देन देयर वुड बी अ टर्म, कैसे लिखें इसको. सो यहाँ पे लिख देते हैं x, and this is p11, and then again x square, and this is क्या लिखूं इसको मैं, p21. और एक काम करो, जानबूझ के जस्ट टू रिमेंबर कि इंडेक्सेस क्या है, इसकी n इंडेक्स है, इसकी n इंडेक्स है, इसकी n इंडेक्स है, इसकी m इंडेक्स है, इसकी m इंडेक्स है, और इसकी m इंडेक्स है. ये याद रखने के लिए सिर्फ. अब होगा क्या, ये इससे मल्टीप्लाई होगा, द फर्स्ट टर्म विल गेट मल्टीप्लाई दिस. सो एक्चुअली हो क्या रहा है, कैन आई नॉट राइट इट इज x की पावर n into x की power m, and then I can write pm1 and pn1 where n and m are both zero. ये पहला टर्म, these two terms when multiplied. Is that clear? देखो इस टर्म में
यस
क्या था, है ना, फिर प्लस करते हैं, इसको पकड़ा, ये जीरो वाले टर्म को ही पकड़ा, एंड देन इससे मल्टीप्लाई किया, तो यहाँ पर क्या हुआ, ये मल्टीप्लाई होगा x की पावर जीरो, एंड देन यू हैव x की पावर वन, एंड देन यू हैव p 0 1, and then you have p 1 1. So यहाँ पर क्या है, ये यहाँ पे n क्या है, m तो है 0 और m क्या है 1. तो यहाँ पे क्या हो रहा है, इस तरीके से टर्म आ रहा है. समझ में आई मेरी बात? फिर थर्ड टर्म हम पकड़ के चले तो क्या रहा है, x की पावर 0, x की पावर 2 एंड देन यू हैव p डॉट 1 एंड देन यू हैव p टू 1. सो हम क्या देख रहे हैं, यहाँ जो टर्म्स हैं वो यहाँ ऐड हो रहे हैं. ठीक है. सो यहाँ पे n इक्वल टू 0 है, m इक्वल टू 2 है, और इस तरीके से आप इसके साथ भी करोगे, ऐसे ऐसे करते जाएंगे. राइट. इज दैट क्लियर? सो समझ में आई है तो बात. सो इज इट नॉट
यस
इक्विवेलेंट टू राइट, इज इट नॉट इक्विवेलेंट टू राइटिंग समेशन n और m 0 से चालू होकर इन्फिनिटी तक कुछ भी हो सकते हैं, मतलब n और m दोनों 0 से चालू होकर इन्फिनिटी तक ही जाएंगे. अब जैसे तुम इसको मल्टीप्लाई करना चालू करो तो क्या आएगा, n की जगह 1 आएगा, फिर m की जगह डिफरेंट पॉसिबल वेरिएशंस आएंगे. फिर इसको पकड़ के चलोगे, n इक्वल टू 2 लेके चलो, यहाँ पे डिफरेंट पॉसिबल वेरिएशंस ऑफ. आर यू गेटिंग माय पॉइंट?
यस सर.
है ना. So this will be equivalent to writing x की power n plus m and then simply writing pm1, sorry, pn1 and then pm1. Is that clear? Let us see ये कहीं option दिखता है कि नहीं दिखता है. So this is your f of x which I feel. So let us see the options and let us see क्या किया जा सकता है. So this is not right for sure. This is also not right because n minus m था ही नहीं. This is also not right. Answer क्या होगा? Is that clear?
यस सर. सर क्वेश्चन में ना x भी मल्टीप्लाई किया हुआ है g1 x के साथ.
हाँ किया होगा. ओके. नहीं पर हाँ तो मैंने यूज किया बेटा उसको. देखो यहाँ पे चेक करो, यहाँ पे x मल्टीप्लाई किया ना, तो मैंने यहाँ यूज किया इसको. देखो पहली चीज मैंने क्या की, देखो समझो. पहली चीज मैंने सिर्फ g1x ही निकाला है, मैंने इसको देखा ही नहीं ध्यान से. इधर देखो. सो यहाँ पे मैंने सिर्फ g1x निकाल लिया पहले, सो दैट एटलीस्ट आई शुड नो व्हाट इज g1x. तो g1x तो ऐसे ही दिए रखा था ना.
यस सर.
ठीक है, तो पहले तो आप g1x निकाल लो. सो g1x आई फाउंड, सो g1x आई फाउंड दैट इट इज 1/1 माइनस x, क्योंकि मॉड x लेस देन 1 दे रखा था, तो 1/, ये गलती होती जनरली, इसलिए मैं बार बार मॉड के लिए कहता हूँ. क्योंकि होगा क्या, जब भी कभी तुम इस तरीके की चीजें इवेलुएट करोगे, रूट ओवर a माइनस बी का होल स्क्वायर, तो तुम जानते हो कि चाहे a माइनस बी का स्क्वायर करें चाहे b माइनस a का स्क्वायर करें, दोनों बात एक ही होती है. बट नाउ यू आर इन अ फिक्स कि किसको आगे रखें किसको पीछे रखें. सो ऑलवेज राइट अ मॉड, अदरवाइज देयर विल बी अ कंफ्यूजन. और जो तुम्हारा वो वाला कंफ्यूजन है, व्हाट आई फील इज कि उन टीएफआर वाले क्वेश्चंस में दे हैव नॉट मेंशन्ड लाइक लिमिट. मतलब they somehow want कि you should understand, because see here they have written mod x less than, because only if mod x less than 1 then only you can start with the binomial expansion of the same.
यस.
नहीं तो मैं एक बार उसको चेक करता हूँ ना. यहाँ तक समझ में आएगी क्या कहती. t की जगह 1 रखेंगे तो
यस.
दिस विल बी, और यहाँ से हमने क्या किया, डेरिवेटिव कर दिया, सो दैट वी कैन गेट रिड ऑफ दिस इंटीग्रल साइन. यहाँ x लिखा हुआ है, if not
ओके.
forgotten. And once we have done 1 minus x square, because the options were such which required us to write it in the sum form, तो मैंने क्या किया, 1 minus x को ऐसा लिख लिया. और 1 minus x को तुम यहाँ n लिख दोगे तो दिक्कत क्या होगी, दोनों मतलब डुप्लीकेट हो जाएंगे, फिर वो तुम भूल जाओगे कि ये अलग था और ये अलग था. So, इसलिए जस्ट फॉर द सेक आई हैव रिटन इट, n डैश लिख लो, जैसा तुम्हारा मन करे वैसे लिख.
ठीक है सर. क्लियर है.
ठीक है, यहाँ पर आई थिंक देयर इज अ क्लैरिटी ऑफ थॉट, इजंट इट? So ये तुम्हारा नेट का क्वेश्चन था. Let us see a few more questions if they are asked, and then we in the next class we are going to start not a new topic but a similar topic to this Legende's polynomial. Okay, just try to do this question first, which I'm giving right now. Just try to find me the value of. Just try to find me the value of. Uh, I think this will be easy question for you. Pn dash 1. So just try to find me the value of Pn dash 1. Should I write it? एक मिनट में लिख ही देता हूँ इसको, जिससे कि confusion now. So just try to find me the value of Pn dash 1. So I'm writing Pn dash 1. And I'm giving you the answer. This is equal to 1/2 n into n plus 1. So always remember that Pn x is the Legende's polynomial. Is the Legende's polynomial, and this satisfies the Legende's differential equation. This satisfies the Legende's differential equation, isn't it? So always remember this. ये नहीं भूलना है day. See, for example, we have not done the how to do a series solution. And I told you I'll record it someday. While I'll record it, because once let us get par in course, and then we'll see all these things. So एक दिन अपन बैठ के जब बिल्कुल we would have done enough course, then we'll see what is series solution and how to go about it. So there are two methods there. One of them is called as power method, other one is called as Frobenius method. So we'll see all those things in detail later on. But right now, just focus on the solution part. So this particular Legendre's polynomial is going to satisfy this Legendre's differential equation given by 1 minus x square y double dot, and I think there was minus 2x y dash, and then this is plus, I think, n into n plus 1 y equal to 0. And if y is the like if it is satisfying this, so Pnx, if it is satisfying, why not write this? So I'm writing why not write this. So this will also satisfy the differential equation, isn't it? I told you that one of the convergent solution is called as Legendre's polynomial of first kind, or simply Legendre's polynomial. So this is what is quite useful to us. So therefore we are focusing on this. Now at x equal to 1, this will go to 0. So you will get minus 2, you will get Pn dash 1, and then you will get plus n into n plus 1, and then you will get Pn1 is equal to 0. And I already taught you that Pn1 is always equal to 1. So this will be 1. So this will be like Pn dash 1 would be equals to n into n plus 1 divided by 2. Is that clear? If someone asks you in the exam, what is Pn dash 1? This is n into n plus 1 by 2. So the crux of the matter is you don't have to forget in entire special function. मतलब जहां भी तुम special function कर रहे हो, let's say Hermite polynomials कर रहे हैं या Bessel's function कर रहे हैं, and if you're giving any competitive exam, because see competitive exam में you will not have time to solve all these things. तो कम से कम दो तीन चीजें बिल्कुल tips पर होनी चाहिए. One, that is the differential equation. Second, that is the Rodrigues formula, if any. So for example, Hermite polynomial will have a Rodrigues formula, Bessel function will not have. So all those Rodrigues formula one needs to remember. Then recurrence relation is one part which probably I will do tomorrow also. But point is this, that is not that easy to do. I'll let you know what to do in exam. And another thing that one needs to remember is orthogonality relation. And बस ये वाला कुछ तीन चार चीजें if you know, you will be able to anyhow do the things in the exam. Probably this question अगर ऐसे नहीं करते और तुम अगर exam में बैठे होते, you could have taken some values for n and m, and probably that may have helped you. I don't know, I'm not very certain. You can try that also. Like you can try that also. Because good part is कि अगर तुम n और m की कोई value लोगे, तो in any case Legendre's polynomial Pn and Legendre's polynomial Pm, they are both 1, because at 1 this will remain 1 only. So अगर ये value तुमने ले ली, तो it will hardly be an expansion of like some powers of x only. So it will make your life relatively easy. well, अगर तुम कुछ n और m की value लेके भी करो एग्जाम, समझ पा रहे हो मेरी बात, मैं क्या कहने की कोशिश कर रहा हूँ? मतलब थोड़ी सी लाइफ सिंपल हो जाएगी. एंड हो सकता है इतना लंबा नहीं दिमाग चले एग्जाम के अंदर, बिकॉज दिस एग्जाम आई हैव गिवन, आई नो, एंड दिस इज व्हाट आई हैड डन इन माय एग्जाम. So, and this is because I was teaching for a while then, and I used to give the exams just because I wanted to be in touch कि मेरे students क्या कर रहे हैं exam पे जाके. So this was the last exam that I gave, as much as I remember. I think this was some 2017 or something. So this was asked in that exam, and so this is how it is. So let us do a few more, and then we'll meet in the next lecture. Just let me know what will be the value of Pn dash minus 1 in that case. Just try to figure out the same steps, do the same step, and you'll be able to find that this is equals to minus 1 raised to power n plus 1, and then all these things would remain. Because remember that Pn minus 1 is equals to minus 1 raised to power. Don't forget it. This will remain as ever. And again, all these things you can do. मतलब ये सारी चीजें आप कैसे कर सकते हो? You just remember 4 of the formulas, that is P0, P1, P2, P3, and you can just place n equal to some value, and then you can reject and select an exam. Because if you know some P1, P2, P3, P4, if it is true for all n, like if this is the statement which is true for all n, then it should be true for some specific values also. So you can use all those tricks in the examination, and that is valid trick. So all you need to do is that instead of x, replace x equal to minus 1 in the Legendre's differential equation. So in Legendre's differential equation, just replace x equal to minus 1. You will get p. So this particular term will go to 0, and this will become 2x, and then this is Pn dash minus 1 plus n into n plus 1, and this is minus 1 raised to power n equal to 0. Is that clear? And overall, sorry, this will not be there. So overall, you will get Pn dash minus 1 is equal to minus 1 raised to power n, और एक और negative आएगा, so minus 1 raised to power n plus 1 and 1 upon 2 n into n plus 1. Is that clear to you? ये चीज समझ में आ गई? ठीक है. So Legendre's polynomial mostly we have done, and we'll see more of it as we go along. Let us do some physics regarding Legendre's polynomial today. At least some physics, so that we can go along in physics also. So we'll keep one lecture regularly on Legendre's polynomial till it is completed to the level satisfaction I want you to understand. And let us culminate this lecture. So I'll join you in the next meeting. So probably I'll share you a new link. Okay.
Okay, sir.
Okay, thank you so much.